Hello everyone. Today we will be studying the chapter on statistics. And to begin, we need to look at our data detective's core tools. These are the three fundamental ways we measure data. First is the mean, which represents the fair share. To find it, you take the sum of all values and divide it by the number of values. Mathematically, this is expressed as A sub m equals A1 plus A2 plus A3 plus A4 all divided by 4, or simply the sum of all A values divided by n. Second is the median, which is the exact middle. You find this by arranging your data from smallest to highest and picking the middle value, using the formula 1/2 times the quantity n plus 1. If there is an even number of data points, you average the middle two. Third is the mode, which simply represents the crowd favorite. You find it by identifying the value with the maximum frequency. These tools work perfectly for a handful of numbers. But what happens when our data sets get massive? When we have too much data, we group it into class intervals, such as 10 to 25 or 25 to 45. However, to actually do math with a grouped frequency table, we need a single number to represent that entire group. We call this representative number the class mark, denoted as x sub I. To calculate the class mark, you add the upper class limit to the lower class limit and divide the sum by 2. Once we have our class marks, we can use our first method for calculating the average of grouped data. This is called the direct method for finding the mean. It involves 3 simple steps. Step 1. Find your class marks or x sub I. Step 2. Multiply the frequency f sub I by the class mark x sub I for each row, and then add them all up to find the sum of f sub I times x sub I. The Greek letter capital sigma simply means summation or add them all up. Step 3. Divide. Using the formula m equals the sum of f sub I times x sub I divided by the sum of f sub I, we take our total of 698 and divide it by 10 to get a mean of 69.8 kilograms. The direct method is straightforward, so why do we need to learn other more complicated formulas? The truth is, the direct method is great for small numbers. But if your f sub I and x sub I values are huge, multiplying them takes forever and mistakes are highly likely. That is why we have 2 other methods. The assumed mean is a shortcut used to shrink the numbers before multiplying. The step-deviation method is the ultimate shortcut, shrinking the numbers even more by dividing them. The golden rule here is that while these formulas look a little longer, the actual math you have to do gets much easier. Let's break down that first shortcut, the assumed mean method. For the assumed mean method, the formula is m equals a plus the sum of f sub I times d sub I divided by the sum of f sub I. The variable a stands for the assumed mean. This means we just guess a middle value from our x sub I column to act as our temporary mean. The variable d sub I is the deviation. Calculated as x sub I minus a, it tells us how far off our guess is from the real number. By substituting x sub I with d sub I, we make the multiplication required dramatically smaller. Now, what if those numbers are still too big to easily multiply? We go a step further. This brings us to the step-deviation method, which is quite useful when your frequency and x values are very large. The formula is m equals a plus the sum of f sub I times u sub I divided by the sum of f sub I all multiplied by h. Here, we introduce u sub I, which is the new shrunk deviation. It is calculated as x sub I minus a all divided by h. We are literally dividing the deviation to make it tiny. The variable h represents the common factor or the class size. That covers our means. Now let's pivot to finding the crowd favorite in a grouped table. To find the grouped mode, your first step is to always find the modal class, which is simply the interval with the highest frequency. Think of it as the winning group. The formula is m sub o equals L. plus the quantity f1 minus f0 divided by the quantity 2 times f1 minus f0 minus f2 all multiplied by h. Let's break down those variables. L is the lower limit or bottom number of our winning group. F0 is the frequency of the group preceding or before the winner. F1 is the frequency of the winning group itself. F2 is the frequency of the group succeeding or after the winner. And H is the size of the class interval. To find our final core metric, the median, we first need to learn a new way to track data. This new tracking method is called cumulative frequency or CF. Cumulative frequency is obtained by adding the frequencies of all preceding classes. There are two types. For a less than type, we start from the top and add frequencies as we go down. This type uses upper limits, reading as less than 20 or less than 25. For a more than type, we start with the total at the top and subtract as we go down. This uses lower limits, reading as more than 15 or more than 20. Armed with a cumulative frequency, we can now hunt for the exact middle of our data. Before using any group median formulas, we must locate the median class. Think of this as locking onto a target. Here is the 4-step process. Step 1. Find the total number of observations and let's call it n. Step 2. Divide it by half to find n divided by 2. Step 3. Look directly at your cumulative frequency column. Step 4. Locate the class whose cumulative frequency is greater than and nearest to n divided by 2. Target locked. That row is your median class. Now that we have a target row, we can plug its values into the master formula. Here is the formula for the group median. M sub m equals L plus the quantity n divided by 2 minus CF all divided by F multiplied by H. Let's define the variables. L is the lower limit of the median class. N is the total number of observations. CF is the cumulative frequency of the class preceding or just above the median class. F is the frequency of the median class itself. And H is the class size. We have now learned how to calculate the mean, median, and mode individually. Let's look at a fascinating relationship between them. As you can see modeled on this scale, these three core metrics sit in a perfect mathematical balance. 3 times the median equals the mode plus 2 times the mean. So, what does this balance mean for our calculations? This represents the magic connection known as the empirical formula. The mean, median, and mode aren't completely isolated. For moderately skewed data, they are linked in this predictable balance. The equation 3 times the median equals the mode plus 2 times the mean is an incredible shortcut because if you know any two of the big three, you can use it to instantly unlock the third without having to draw a single frequency table. Speaking of drawing, let's look at how we visually graph our cumulative frequencies. We can represent our cumulative frequency tables graphically using curves known as ogives. A less than ogive is plotted using the upper class limits on the x-axis, and you will notice that its curve goes up. Conversely, a more than ogive is plotted using the lower class limits and its curve goes down. And for our grand finale, what happens when we plot both of these curves at the exact same time? The reveal is stunning. If we plot both ogives on the same graph, they will intersect at a single point. The magic here is that a perpendicular line dropped directly from that intersection point cuts the x-axis to give us the exact median. By doing this, you have just found the exact middle of complex group data without using the formula at all. And that wraps up our visual journey through statistics.